Shake Table Towers by Rhys and Jake North. Before we began building, we created a construction sketch on Sketch to give us an idea of what our tower might look like. Although our tower did not end up looking exactly like the plan guided us through the beginning steps of the building process. The building code stated that the tower's first and second floor both had to be at least 18 centimeters, and the tower had to have a decorative rooftop. Mr. Closet drilled holes into our cardboard base so we could insert straws into them. We folded the ends of the straws and taped them to the bottom of the cardboard base, which helped firmly secure the uprights of our tower. My partner and I added V-shaped supports along the sides of the tower for strengthening. In addition, we added straws horizontally on the middle of the sides for more added support. To increase the strength of our tower, we added even more vertical supports along the sides of the tower. Doing this created smaller triangles which are much more powerful. In addition, we added paper floors to hold the weights. Finally, we added a decorative rooftop for design. The rooftop was the artistic section of the tower. The variety of colors on the roof made it look better and much more beautiful. Jake and I measured the tower's base, its floors, the roof, and the height of the tower. The base is 23 by 23 centimeters. The height of the first floor is 19.5 centimeters. The height of the second floor is 18 centimeters, and the rooftop is 23 centimeters high. Completely, the tower is 60.5 centimeters tall. For static testing, we used 2 sandbags on each floor, which is equivalent to 1,000 grams. Static testing let us know that our tower had sufficient strength and was ready for shake table testing. To strengthen our tower, we added triple straw uprights and V-supports along the sides. Adding the supports drastically increased the strength of our tower from all directions. I think the strongest part of my tower was the triple straw uprights. They added an incredible amount of strength and stability to my tower. Out of the whole tower, I think the weakest part was the taping job on the first floor. The tape wasn't secured properly, and I think it was one of the reasons why our tower failed so early. We had to make sure the straws and paper were attached securely, so Jake and I used tape. Doing this ensured that everything stuck together and would not fall apart. The main extra supply I used for my tower was paper. I attached 2 pieces of paper to divide the tower into 3 sections and be a placeholder for all the weights we were going to put on the tower. We put our tower on the shake table. It successfully held 8 sandbags during a major earthquake.
Major earthquake.
Our tower finally collapsed while trying to support 12 sandbags. X waves represent side-to-side motion, Y waves represent forward and backward motion, and Z waves represent how much the tower bounces up and down. As you can see, the side-to-side motion was most significant, then forward and backward motion, and finally, the up and down motion was the least significant. Hi, my name is Rhys. During shake table testing, our tower supported 10 sandbags and fell while trying to support 12. Our building failed when the cross supports detached from the tape, which resulted in the tower falling. I could have secured the cross supports with more tape to make the building much more stronger. In addition, adding more supports onto the first floor would have helped. During the building process, I learned that cross supports along the sides of a building make it much stronger and more earthquake proof. Also, I learned that triangles are the strongest shape. I enjoyed collaborating with my partner and learning about earthquake-proof buildings. I also enjoyed shake table testing. Thank you.
Hi, I'm Jake North. During shake table testing, our tower supported 10 sandbags but collapsed at 12. Our building failed at a joint of the cross supports on the first floor because the weight of the second floor and the rest of the tower was all on it. The tape broke and the tower collapsed. If I could make any changes to my tower right now, I would probably add more supports on the first floor because this is where most of, or pretty much all of the towers collapsed. Something I learned about building an earthquake-proof building is that triangles are one of the strongest shapes that you can use, and I also learned that the first floor will likely be the weakest because it has the weight of all of the other floors on it. One of the main things that I enjoyed about this lab was collaborating with my partner, and I really enjoyed learning about building earthquake-proof buildings.